Hi, Chinthaka.
Hello, Bobby.
Yeah.
Yesterday I asked you how to measure the weight of a truck.
Yeah, yeah.
Right. Using a strain gauge, and you surprised me. You said you have a platform and 4 different
Yeah,
load
we
cells.
used something called load cell.
Load cell,
Yes.
right? So then it got me thinking
Mm.
because I thought there'll be another different way to measure the weight of trucks. Are there any other crazy applications
like
of,
this.
of the load cells? I mean, truck is not really crazy, but I'm
Yeah,
thinking.
yeah.
Uh,
What about maybe a rocket?
rock. What are you going to measure for a
I
rocket?
wanted to see what's the thrust of a rocket.
Oh, measure the thrust of a rocket.
Yeah.
How would you do that?
So I looked at, how people have done this.
Uh-huh.
There are some, nice way of using a load cell, but a special load cell to measure this.
Oh, so you can use the loads.
It seems. Maybe my drawing will not be proper, but let's say we have some rocket like this, where flames come this way, and this guy is moving up. Okay. What we wanted to know is what is the actual force generated by these flames.
Mm-hmm.
This
Movement.
in this direction. Because I want the rocket to go up, not in the east. Correct?
Yeah.
So, I actually wanted to know what is this force. And that measurement should not get affected by, let's say, there is a force in these directions.
Uh-huh.
That should not create any influence on the vertical force measurement.
Right. I guess that's important if you want to go straight up.
Correct. So basically, we are looking at what is this force, and I don't want this to be dependent on force in any other direction.
So I guess there are forces in other directions too.
It's possible.
It won't be perfectly
Yeah.
straight.
Yeah. Right. So, of course, it's difficult to measure while it is moving. So you have designed it, you have fabricated it, and you want to actually, like a crash test of cars.
Yeah, the dummies.
Yeah, you go and hit on a wall and then see what's the force experienced by all key parts.
Correct.
And the driver, dummy, and so on.
Right.
Very similar one.
Right.
So I have a nice diagram.
Oh, what is this?
Look at this. Of course, here the rocket is this one. It's not kept in the vertical direction. Doesn't matter. They have placed it on a sliding platform.
Okay.
A platform which is free to move in the horizontal direction.
Right. And this so-called rocket?
Yeah. So this rocket, let's say you fire from this side, it will try to move in this direction.
Uh-huh. Uh-huh.
And what they have done is they stop that movement using a load cell that is introduced here.
I see. And then this rocket is clamped to the sliding platform.
Yes. Yeah. The rocket is clamped to the sliding platform. So basically, when the rocket moves, the sliding platform just holds it and allows it to move in the vertical direction.
Otherwise, it will just go.
Yeah, if it so there will be friction.
Yes.
If we directly keep here without a sliding platform, there will be friction.
Yes.
And that may also affect our measurement.
Right.
So we want the rocket to move freely in this direction, and it has to be due to this activity, of course.
Right.
So the kind of design is like this. You have a load cell, you are measuring. Now, how much is the force given to this load cell by the rocket?
Right.
There is a triggering mechanism. You trigger the firing of the rocket is by this trigger. It comes and hits. The force is recorded using let's say, computer system.
Okay.
Let's not go into details of how that is realized, etc. But the key thing is, as I explained in the previous one, I wanted to measure this alone and not these two.
Yes.
Right. When I say repeatedly that, what it means is, suppose if you use let's say this is our pocket, And suppose if I use a load cell to measure, of course, the load cell size is a bit large here, but let's say if I have something like this, and imagine there is force in, let's say in this direction, okay, along with the actual thrust, right? So what will happen to this load cell?
I mean, it will bend. Okay.
Yeah. So in the sense, ideally we expect, I mean, if there is only vertical force, in this case horizontal, yes, it will get compressed. Yes, correct. But now in this case, because of this component, there will be a bend, as you said. So I will, it's a
So the impact will be
exaggerated view, but it gets bend like this, right?
So it's slightly misaligned somehow with the at the impact.
Yeah. So
Then it causes a bend.
yeah. So, but if it was just vertical alone, it will be just compressed, right?
And how far do you normally keep, let's say, this rocket face?
That exact details we have to check, right?
But pretty close, I guess.
It is. I mean, it's not the impact that we are measuring.
Yes,
It can be actually touching, I think, initially itself.
right. This is a force.
Yeah. It's not the impact that we are measuring. It's the force that is created by
the fire.
Right. Now, to elaborate this further, I mean, see, this structure, it could be a circular shape one or let's say a square shape one. Correct. The shape of, I mean, the face of the, right? Let's say we go for this one. Then I have a different diagram. Yeah. Then it will be something like this. Yes. I've kept it vertical here, but if you look, it has a platform wherein one side of the structure is pitted. Then you have this cross-sectional view will be a square-shaped one. So here we have strain gauge which is sensitive to this direction, and on this face there is a strain gauge which is sensitive to this direction. So like we explained in the previous class, when it undergoes compression, there will be expansion in this direction. So basically this guy is sensitive to that and this guy is sensitive to the compression itself. Okay. The other two faces will have similar, I mean, there will be one more that is sensitive to compression and there will be one more which is sensitive to the expansion. So you get that 4 sensing elements in the push-pull fashion. So you can form the full pitch, right? Now, if this gets bent from here, so for example, let's say this gets bent. I mean, let's say there is a force in this direction also. So that means I'll just give an exaggerated view. Let's say this face, I mean, whatever we see here, let's say that gets bent in this direction. Or we will take maybe R1 and its opposite face. Let's consider this. Let's say R1 is in this face and let's say R3 is in the other face. Okay. And R1 is here. This is R1. And let's say this is R3. Okay. R3. Yeah. Is it R2? I guess R2 is this one. Yeah. So R3 is in this space. Yeah. On the opposite face. So when we made the full bridge, it was something like this. This was increasing and this was decreasing. Yes. You have kept it in this fashion. Correct. Now, maybe let's name in this way. Let's say this is R1 and this can be R3. Sorry. So in this case, maybe we'll let's say this is R1, because when it compresses, its persistence decreases. So, R1, R2, R4, R3 and R4. No,
The R4 there.
R4 and yeah. So, R1 and R3 are in opposite phase, both decreases. R2 and R4 are in the, again, in the opposite phase. So, they both will, yes. Now, what I am saying is, suppose there is a component of force in this direction. In that case, maybe I will use a different color. Of course, it's an exaggerated drawing. Let's say it gets bent this much. So, now if you look here, due to the bend, this area is going to gets elongated,
Yeah.
correct? Yeah. And R3 will reduce further. That gets compressed, yes. So, there is some unwanted effect here.
Correct.
I mean, what we were looking at is unwanted in the sense, we were looking at the force in this direction alone. We were not expecting a bend like this. But because the input force has a component in this direction, in the horizontal direction, there is a bend, and then that alters R1 and R3 in a different way than we were expecting.
In addition to
the original force component. So, basically, I am not in a position to say this is the vertical component. I only have combination of all this and then some.
Yes. I mean, if you have a reference, then you'll be able to say there's some bend which is why you're getting some Newton, but now you probably won't.
Correct.
What about the other two sensors? They will also have some effect.
They will also have some effect depending on the phase, what it goes through. Right. But if it is a bend in, if this phase bends in that direction, yes, maybe both of them will have similar effect if both of them are in the expansion mode.
Correct. Yes. Otherwise, the bend should be in this other direction.
Yes.
Yeah, you're right.
Yes. So, essentially what we're saying is there can be bend and that can affect the measure analysis. How do you solve this problem?
So, you're saying, given that there's a bend, you want to find out the real vertical, let's say this is vertical, right? You want to find that.
Correct.
So, you're saying there is a way.
Yeah. So, what these people have come up, of course, here we were taking output and so on. So, these authors, they came up with a nice solution.
Okay.
Well, let's see that. So, instead of using a 4-phase structure, now they have a structure with 8 phases. This element. Okay. So, 8 phases in the sense, suppose if I make a cross-sectional view, cross-section here. If I cut and then look from top, that will look like this.
So, 8 resistors.
Yeah. So, you have got 8 separate phases now. Okay. And you have the option to have 8 sensing elements there.
Okay.
And as you can see here, the sensing elements R1, R2, etc. up to 8. This is 8. Are arranged in a, as we have done in this case, this was sensitive to this direction, this was sensitive to this direction, and so on. Yes. And alternatively, it is arranged. So, in the same way here, R1 is sensitive to vertical direction, as you can see here. Yes. And R2 in the next phase is sensitive to this expansion and contraction. I mean, when you apply force, there is an expansion. So that is sensed by R2. And then R3 again, which is made sensitive to the vertical, the compression. Right. So like that, we have 8 sensing elements. Now the question is, what are you going to do with this 8 in the sense, how are you going to solve the bend issue?
How are you going to compensate?
Correct. Right. Now, if you look here, let's say R1 and R5, both are supposed to undergo same type of either elongation or contraction, depending on the force you are applying.
Yes.
If it's only downward force, it will be contraction and resistance will decrease. Yes. Now, if you look here, these two are in the opposite phase.
That's R1 and
R5. Yes. Okay. Right. Suppose if I keep both of them in series in the same arm. I mean, earlier we had 4 resistors, now we have 8 resistors.
Okay.
Or 8 sensing strain gauges. Yes. So we can have maybe 2 of them in one branch, like this.
Okay. So they're in series, basically.
They are in series. Yes. So maybe I can keep R1 and R5 in series.
And they're in opposite directions.
Oh, they are anyway in same, sensitive to strain in same direction. So it can get add.
Okay. Correct. If you have it in series, it will add.
Yes. So it's like R1 and R5 together giving a change in resistance.
Okay.
So when there is compression, there will be reduction in resistance. It will happen to R1 and R5.
Correct.
Similarly, I can put maybe R3 and R7. Let's say R3 and R7 in another branch. Okay. And so on. R2 and R6 in another one, and R4 and R8.
But then R3 and R7 will have the opposite effect to R5 and R1.
Yeah. So what we will do is, here we said they are going to
increase. Add.
Yeah. When there is force in this direction, they will decrease. Contraction. So these two will decrease. So if so, I will keep the other branch increasing, correct? Yes. So if you look here, R2 and R6, I can put in series and keep here. Yes. And so on. Right. So I have a diagram coming, but the point is now, if you look at, let's say, R1 and R5, back to R1 and R5. Let's say there is a component in this direction, the force component in this direction.
Okay.
Right. So what you're saying is, what you're saying is, I think R5 is not visible here, R1 is here. So along with this force has got a component which is out of the plane. It's difficult to draw. So that is there, right? Or the way I have drawn, it is into the plane because it's going towards upper, right? So what will happen? There will be a small bend towards R5.
Yes. So then R1 that will kind of elongate.
Yeah, exactly. So R1 will have an increase in output. Increase in resistance.
Yes.
And R5 will have a decrease in output.
Oh, okay.
Due to the same bend.
Right.
Correct? Yes. So as this guy decreases and this guy increases.
So it's the same.
So this series combination will not have any effect here.
And that's when you know that there is another component affecting the...
Yeah. So basically, although there is other component,
yes. This
now your bridge is, or that bridge arm is not sensitive to here.
Yes.
It is sensitive only to the vertical.
Vertical.
Yes, yes. So this idea is expanded to other branches.
I mean, it is sensitive, but they cancel.
Yeah,
right.
Yeah, the branch by itself is not sensitive.
Sensitive.
While individual elements are sensitive.
But they are in the opposite direction, so they cancel.
So that's a simple, nice idea. If you look here, R2 and R6. R2 and R6. Then if there is a bend in this way or this way, yes, again it will get cancelled. Yes. Similarly, R4, R8. Yeah, this one. And so on.
That's a very nice way.
Yeah, it's
simple,
exactly,
but very effective.
Exactly. So, I mean, without doing no additional, what shall we say, computation or nothing. I mean, from the sensing point itself, you have resolved that problem.
Yes.
And giving out only what we want.
Yes. But the structure itself was slightly modified.
Exactly.
You know, from 4 phases to 8 phases.
Exactly.
But apart from that,
yeah,
right, you just increase the number of sensors and there. Well, that's a very nice way of solving the problem.
Yeah. Yeah. So that's another interesting application.
Yes, that's actually very interesting. That's an extreme application.
Correct.
Yeah, right.
Yeah, this is something we are not going to come across.
No, it's a niche application.
Yes. But there is some learning from this. You know, this we may be able to use it in some other application. Yes. Even the same, what shall we say, truck that we mentioned. I mean, when you enter the truck, there will be force in other directions also. Maybe it doesn't matter for the weighing measurement. But if you want to measure certain type of force, I mean, if you want to measure only vertical component, even once component is force component is present in other directions, this kind of structure can be used.
And the nice thing about this is that, normally you think a sensor is just one kind of component, but really with strain gauges, you see that the structure it's on
exactly
can also be modified in ways like you talked about taking material out.
Correct.
And put in the strain gauge.
Correct.
Now, in this case, you're saying now there's 8 phases.
8 phases, right? Yeah. In fact, I think, the center is removed. This portion, it's a kind of a cube.
Yeah. Right. You see, I mean, so and before with the sensors we talked about, we did not really see that the sensor itself is the component. But in this case,
correct,
it's like you have 2 different kind of components
exactly,
where you can play with it.
Exactly.
Which is very nice. Yeah. Because then you have a lot of applications because of the method.
Yes. So
no, that's nice. I did not expect application like this strain gauges, but so that also means you can use it in very harsh environments, I guess, in a lot of ways.
Yeah. That way, these kind of structures, the load cells, are quite rugged. You can, let's say, even if it is dropped from your hand or things, nothing is going to happen. This is made of very strong material, yes, or stainless steel and things like that, which can handle tons of mass if it's required. Yes. And strain gauge is just an attachment to that to sense this strain.
Exactly. I think that's the beautiful thing about strain gauges, right? You can attach it to these kind of structures. And you also said with the Wheatstone just the other day, you mentioned that the temperature compensation.
Correct.
Right. Again, with these have the alpha.
Yeah.
Then you don't have to worry about the temperature.
Exactly. Same applies here. I mean, since you have the full bridge, it's insensitive to change in temperature.
Very nice.